Hello everyone, and welcome to another Flowcode app developer tutorial video. Today I'm going to be looking at the SCADA slave hardware again and making a little example project to create a passive component tester. To get the SCADA slave hardware running, I'm going to go to the Flowcode wiki, which is flowcode.co.uk/wiki. I'm going to click on the component library link, and this lists all the various components within Flowcode. If I scroll down to the API SCADA slave section, you can see that we have a page assigned for each of our current SCADA slave platforms. If I click on the Arduino Uno, then this provides me a link to the latest firmware and also a mapping of the various I/O, so the digital and the analog channels and which pin that would correspond to. I have a version of the firmware loaded up here, and all I need to do is open it in Flowcode 9, click Build, Project Options, change the programmer port to match the port of my connected Arduino, hit Modify, and then click the Build Compile to Target button. Asking me to save the project, and it's asking me to connect my Arduino. OK. And here you can see my Arduino board is programming, 2 LEDs lit up, and then here we have programming successful. So that's the SCADA slave firmware loaded on the Arduino and ready to go. So I have my component test project. Now I've been discussing this on our forums, so that's flowcode.co.uk/forums. And here under, I'm not sure where we are actually, let's have a quick look. On the index, General, under General, I have an electrical test component tester section, category. Here I've published the SCADA slave firmware link and also my app creator project, as well as a little hookup schematic, and then basically gone through how I'm getting on and maybe ways that we could improve this in the future. So if we go back to the project, then on the panel properties, I've exposed things like COM port for the SCADA slave component. So I've basically come here, right-clicked it, exposed to top level, and that's providing me this COM port here. So this is the connection to the Arduino Uno. We have various things such as the supply voltage. So some microcontrollers might be at 3.3 volts. We have the bit depth. So some microcontrollers might be capable of 12 bits ADC conversions, or maybe only 8 bits. We have the series resistor, and this is the resistor here specified between D2 and A0, and I can change that as I need to, and that will update on the panel here and update all the various calculations within the software. This is sort of an arbitrary value, and we recommend it doesn't go below 330 ohms just to save the just to protect the I/O pins on the Arduino. Currently I've connected an 11K resistor, and if I just move my hardware slightly, you can see that I have 3 pins coming from my Arduino to my breadboard, and this is my series resistor. So that's my 11K resistor connected between pins D2 and A0. This is the value that we're going to test. That's the 1K resistor. So let's see what values the program can give to us. So all I need to do is check that my COM port is correct, which it is. I check that the pins are correct. So the high pin is D2, the low pin is D3, and my analog test pin is A0, and then I just simply click run. You see that on the console it's saying that the Arduino SCADA has been initialized. If I click test resistance, 996.9R. So that's very, very close to where I was aiming for at 1000 ohms. So now if I remove the resistor, instead place a capacitor, we can test the value of the capacitor. So I have the positive side of the capacitor connected to pin A0 and the negative to pin D3. I click test capacitor, test capacitance, then the capacitor will discharge to get it into a known sort of stable state, and then as soon as we're discharged, we'll charge it up, monitor the rise time with the series resistance in mind. And here we've got a reading of 80.9 microfarads. It's not brilliant, but it's reasonably close to the 100 microfarad capacitance that we have connected. If I click it again, let's see if it gives us a slightly different reading. Discharging, and then we're charging back up. Oh, this time we've overshot a bit with 118. As you can see, it's not perfect, but hopefully with a bit of time and a bit of practice we can improve and keep working on this. It shows that some of the things that we can do with the app developer software. So once I have this, I can now, if I stop the application, if I go to File, Export, I can deploy this as a Flowcode app. Yes, I want to save. There's various options, but I want my main view to be the 2D dashboard panel. I don't want the 3D system panel. I always want the properties to be shown. I want the console to be available. I'm not bothered about the data recorder. I want to bundle the app developer runtime, and I want it to be called component tester. I click deploy. It allows me to specify the folder that it goes into. I'm just going to place that on my desktop for now. Success. So now if I close my Flowcode project, and if I open my find it, here we go, the component tester folder, and inside there we have the .mscada project file as well as a batch file to open it up for us, and the app developer runtime itself. So if I double click on the batch file, it loads Flowcode app developer. So you can now share this folder to anyone you like who don't need Flowcode installed, and this will all just run as is for them with no installation required. I can specify my COM port, so just check that the COM port's correct, everything as was, and then I can, as before, do capacitor and resistors tests. Now we have various requests on the forums to add things like inductors, transistors, MOSFETs, triacs. I think all of this is possible, and I'm going to try and see what I can do. But obviously, my time is quite stretched, so I would really appreciate if anybody fancies jumping in and helping with any of these projects, or even taking them on and turning them into their own projects. That would be really, really brilliant, and I'm really keen to see this sort of thing happening. Again, the forum is a brilliant place for you to let us know what you'd like to see, or to share what you've been doing. and I hope this demonstration has been useful. Thank you very much for watching, and I'll see you later.